Welcome to Super Easy Physics and Mathematics SEPAM. Today we are looking at the solution to Physics Alternative to Practical Paper 6, February-March 2023. This paper is solved and explained in detail. It's recommended for every student, a must-watch before you write your next exam. You are expected to answer all questions, and the total mark for this paper is 40 marks. Question 1. A student determined the diameter of a marble by two methods and calculate the density of the marble from the methods. Some marbles are in full size as shown in this particular point. So the student decides to, what is the diameter, the length D? He decided to measure by putting this ruler, and why he decided to measure this one is because he wants to reduce the uncertainty of measuring one of the diameter of one of the marble, because the marble is very small, and so there is a high risk of having wrong measurement. But if you pile them up and take a repeated value, you can reduce that error. So what is the length of these 5 pieces of marble put together? So you have this value here, which is 7.5, 7.6, 7.8 cm. Using the value of the total length for the 5 marble, calculate the average diameter for one of the marble. So since 5 marbles put together had a total length of 7.5, so what is the length of one marble? All you need to do is to divide the total length by the number of marbles measured together. So that gives the length of 1.56, which is approximately 1.6 cm. Suggest why it is more accurate when using a ruler to measure D for 5 marbles rather than measure the diameter of a single marble. I've said it reduces the effect of uncertainties. The diameter of the marble varies and it is not constant. Method 2 shows 2 wooden blocks and one of the marble. Describe how the student uses the 2 blocks and the marble to determine a new accurate value for the diameter of a marble. Draw a diagram to show the arrangement. Describe clearly how the student ensures that the value of the diameter of the marble is as accurate as possible. So what you need to do, all you need to do is to pick one of the marble and place the marble and pull the wood together to make contact with the marble. So pull the 2. So from there you can now measure the length between this wood using these 2 wood. So that reduces the uncertainty. So if you are using this one, that will be about 1.1 cm. So for this length of the marble. So by using this method, so to ensure accuracy, he rotates the marble for different axes and take average of measurement. Because most times the marble is not smooth and the marble might have different diameter. So he measure it, rotate the marble, and then measure it from different angle. Then at the end you can find the average. So that will eliminate the error in measurement. Now what we have just done here is thinking and working scientifically. This is an aspect of the curriculum which involves taking appropriate and accurate, precise measurements, explaining why accuracy and precision are important, and then also in this physics practical course you are expected to evaluate whether the measurement and observation that have been made are repeated enough sufficiently to make it the investigation a reliable one. So that's, you look at this one. To ensure accuracy, what do? You repeat the measurement from different axes. So you look at this aspect here. So let's go. Now the student used the top pan, that is this, as shown, to measure the mass of the 5 marble, because for you to determine the density of the marble, you need to know the mass of the marble and the volume of the marble. So what they did the first time, we just measure the diameter. So let's find the mass of the marble using the top pan. So first thing, you have to measure the mass of the empty beaker that he used to measure the mass. The beaker is 30.8 grams. Then he decided to put 5 pieces of marble inside the beaker, and then the mass increased to 64.3. So what is the mass of the empty beaker? 30.8. And what is the mass of the 5 pieces of marble? That is 64.3 grams. Then from here we can calculate the mass of the one of the marble. So all you have to do is to divide it by 5. Use the value to calculate the average mass of one marble. So since the 5 marble together is 64.3 grams, then the mass of the empty marble is this. So subtract this to know the total mass. So for the 5 pieces of marble have the total mass of 33.5 grams. So to know the mass of one marble, divide this value by 5. So that gives 6.7 grams. The unit is already written. The student pour water into the measuring cylinder, and he records the reading V1 of the water level in the measuring cylinder, that is 20. So let's look at this. This is the measuring cylinder. Now the student decided to put the 5 pieces of marble, and the length of the water rose to this point, but the initial level was 26. So the water level rose to this, and if you want to measure, you always measure from the lower meniscus, which is the bottom of the curve. So let's see, we'll measure this. That will give the new volume, that is V2, rose to 38 cm. The volume is 38 cm cube. So let's just explain. Now what happened, we are using the displacement method to find the volume of the marble. So to do that, the initial volume was 26 when there was no marble inside. The initial volume of the water in the cylinder was 26 cm cube. Then when he added the 5 pieces of marble, the volume rose to 38 cm cube. So from there, this is the increase. So for you to know the volume of the marble, all you need to do, you subtract it. That is about 12 cm cube for 5 pieces of marble. So let's find the value of one of the marble, volume of one of the marble. So calculate a value for the average volume of one marble using this formula. The final volume after the marbles were added, then take away the volume of the water in the cylinder before the marbles were added. That gives 12 cm cube divided by 5. That gives 2.4 cm cube for the volume of each of them. Calculate the value of the density of the material which the marble is made. Use your value of that already calculated in C1, then V from C3 above. So let's bring the value. So you have the mass of the marble, which is 6.7 grams, and then the volume of one of the marble, 2.4 cm cube. So from there you can get the density, which is 2.71, approximately 2.8 grams per cm. Describe one possible source of inaccuracy in the method described in C. So and suggest one improvement to reduce its effect. I think the major is have to do with. So this question is testing your scientific inquiry, your ability to carry out analysis, evaluation, and conclusion. So, and under this aspect of the course, of this question is you are expected to evaluate experiments and investigation, including those by others, because this one is the one that is done by the examiner. So including those done by others, and suggest improvement, explaining any proposed variation that you can do to the setup. So let's look at this question that is testing this aspect of describe one possible source of inaccuracy in carrying out this investigation of measuring the density of the marble, and suggest one improvement to reduce the effect. So explain any proposed variation that you can suggest. So let's look at it. What is the source of this? So first of all, the graduation on the measuring cylinder, if it is too large, it will introduce error. So I just look at this. So if this is a measuring cylinder, the gap between calibration, if it's too much, so let's pour liquid inside. If you pour liquid and then the liquid get to this point, so let's say the liquid get to this point, is not specifically on any calibration. So how do you say the value here? Assuming this is 2 and then this point is 6. So if it is 2 cm cube and then this one is 4 cm cube, so how do you know exactly the position of this? So this can introduce error into your measurement. So what can you do to improve the measurement? That means you have to use a measuring smaller calibration, closer calibration, and then you can use greater number of marbles. So the higher the number of marbles, then you can now find the average. So that will make your measurement more real. Question 2. A student investigates the cooling of hot water from different initial temperature. So she uses the apparatus shown below. So you have the thermometer, the beaker inside the room, then the hot water that is poured inside the room. So she measures the room temperature, record the room temperature with the thermometer. So if you look at this, and then this is a question that is going to test carrying out scientific inquiry. So your ability to collect, record and summarize sufficient observation and measurement in appropriate form. So how do you read the initial temperature of the room, and how do you read the temperature of the water as it drops using the thermometer? So let's see. If you look at this value, so this one is about 21 degrees Celsius. So we have done that measurement. So if you write this, the unit is given, but if the unit is not given, you are expected to write down the unit. Because the unit is given, just write down. Describe one precaution that the student take to ensure that the temperature reading is as accurate as possible. So if you want to read it, so you have your thermometer and you want to read it as it is rising, one thing you avoid, you must make sure that the mercury or the liquid that is expanding stop rising before you take your measurement, 1. And then 2, when you want to take your measurement, position at perpendicularly to this calibration, to the scale. So what I mean by this, position your eye. So your eye must position vertical. So the reading here is 71 degrees Celsius. But if you position your eye from another angle, not perpendicular, so if you look at it, maybe a student is looking at the temperature reading from this particular direction, which is not perpendicular to the calibration, what he or she is going to read is a value less than 71. So it's going to read 69 degrees. So 2 students are reading the same temperature. So one is correct and the one is wrong. So if you view perpendicularly, that gives you a better correction. So view the scale reading perpendicularly. So that is one precaution you must. Then the second precaution is ensure that the rising or the beat of the mercury stop before you take your reading. Now, Experiment A. The student pour a volume of 10 cm cube of hot water into the beaker and record the initial temperature at T equal to. She records the temperature of the water in the beaker every 30 seconds as the temperature is reducing. That is the cooling rate. Her reading for experiment A are shown to 1. So then the student repeat the process. She waits until the initial theta B of the water is the same as that of theta A at 90 seconds for experiment A. In the first line, record her initial reading. So the student did the first beaker that she used had the initial temperature of 92 degrees Celsius. And then she measured the temperature as it dropped every 30 seconds. After the first 30 seconds, the temperature dropped to 89.5. Then after 60 seconds, it dropped to 87 degrees Celsius. After 90 seconds, it dropped to 85 seconds. Then after 180, it dropped to 80 degrees Celsius. So what is the temperature drop for the first attempt of carrying out the experiment? So in 180 seconds, the temperature by F degree. So you can calculate the cooling rate. So the temperature drop divided by the time taken, that will give you the cooling rate. Now, the student repeated the same experiment using the same beaker, but this time she allowed the temperature to drop to 90 seconds. So the temperature there that she now used before she started recording 30 seconds, before she started taking her reading. So she allowed the water to cool to 85 degrees. So that will become the initial point for experiment B. And then she did the timing for the next 180 seconds, and the temperature dropped to 95 degrees. Write a conclusion stating how the temperature 0 seconds after they affect the cooling rate of the water. Justify your answer by reference to value from. Now, the most important thing you should know here is that looking at the temperature for beaker 1 for the hot water, the cooling rate is faster. So let's look at this one. For the first beaker, the temperature 92 degrees Celsius to 80. So subtract this from this, that will give you about 12 degrees. Then for the second one, the temperature dropped from 85 degrees Celsius to 95. So 85 to this, that is about 10 degrees. So the temperature difference between the two of them is about 2 degrees Celsius. So for within the same time, so that means the hotter the liquid, the higher the cooling rate. So let's look at it. So in 120 seconds, the temperature of beaker A reduced by 12 degrees, while beaker B reduced by 10 degrees. So that's why I say that the water in beaker A with hotter initial temperature 90 degrees has a higher. Calculate the average cooling rate S1 during the second half of experiment A using the value. And so using the second half of experiment A, so you have what the first half, you have to 180, so 85 to 80 degrees. So what is the cooling rate there? So you have 85 to 80, that is about 5. So you divide that will give it 0 degree per second. So let's look at the next question. Calculate the average cooling rate during the first half of experiment B. Use the reading. So the first half is from theta B0 to theta B90. So from theta B naught, so the temperature dropped from 85 degree to 79.5 degree. So in 90 seconds, that's from 0 to 90 seconds. So substitute, that will give 0.061. So where T, you already know that, so evaluate the cooling rate for the second experiment, which is 0.061 degree Celsius per second. A student suggests that S1 and S2 should be the same. State whether your results support this suggestion. Justify your statement by reference to your results. So anytime you look at questions that have to do with justification, what you need to do, whatever answer you are giving, should be your ability to interpret the table, the data already collected. So you make reference to it. So that you say, justify your statement by reference to your result. So if you write anything without making reference to the results that they are used for the investigation, you will score 0. So the first statement is the results support the suggestion. So why do I say it support the suggestion? Now, the temperature change for this first half year is 5 degree. So if you look at it, 5 degree was the temperature change. That is from 85 to 80. 1 year is from 85 to 79.5. So the difference is just 0.5 degrees Celsius. So which is very small. So within limit of experimental accuracy, 0.056 is approximately 0.061 degree Celsius. State two variables which must be controlled so that the comparison for S1 and S2 will be valid. So what we are looking at for the result for your experiment to be a fair test. So we are looking at scientific inquiry, purpose and planning. Now make prediction of likely outcome for a scientific inquiry based on scientific knowledge and understanding. Then plan a range of investigation of different types while considering variable appropriately, and recognize that not all investigation can be fair test. So what we are looking at now is you are carrying out a fair test. If the material that are used for carrying out the cooling test are not constant, you don't have a reason for you to carry out the comparison of the results that are obtained during the investigation. So first thing you want to do, you have to make sure that you start with the same initial volume of water in the beaker. And then secondly, you use the same type of beaker. If you use a different beaker for experiment B, for the cooling experiment, then you can't compare the value because the beakers are different. Because the thickness of the beaker may be different. Then you must use thickness. Then you must use the same surface area and shape of beaker. That's why the beaker must be the same. If you are comparing, then the same room temperature, initial room temperature must be used experiment if you must compare the cooling rate for experiment A. Now question 3. A student investigates the property of the resistance of a wire. So you have a wire of this length, then connected in diameter resistor to keep current constant. You have a switch, power source. Then what the student will do when you want to carry out this experiment is that you use the crocodile to set the length of the wire. Then you measure the length of the wire using a ruler, and for this case the student measure the length of 20 cm. Then you take the reading of the current flowing, and then you measure the potential difference across the wire. So how do you measure potential difference? You connect your voltmeter in parallel to this wire. So you do that. So with that, you draw that, you have gotten your 1 mark. See, now the student connect the crocodile clip of 20 cm of the wire. He measures the value of the potential difference and the current. So this is the V difference, then A is the ammeter. The voltmeter reading is 1.3 volts, then the ammeter reading is 0.86 ampere. So if you look at this reading, then read out the first line of the table. The student repeat the process for the length of constantan wire for 40, 60, 80 and 100 of the ton. His results are shown in the table below. So we have this table. So when it was 20, these were the reading, the voltmeter and the ammeter. So transfer it there. Then calculate the resistance by dividing the voltage by the corresponding current. So that gives 0.51 ohms. So when we have that, so write that, which is make it consistent. That is 1 ohm. Now plot a graph of resistance on y-axis and the length on s-axis. Draw a straight line of best fit. So if you want to do that, this question is having a total 4 marks. How do you get the mark? If you draw the axis and you just label it like this, you have 1 mark at this point. Then you have your scale from the value. So this the vertical axis, the resistance. The resistance of the wire, you have the lowest value of 1.5 ohm and the highest value is 8.3 ohm. So you can share into this axis. So this here will be 2, 4, 6, 8 and 10. So you have distributed it evenly. So if I do this, I have half mark. Then I will now look at the length, which is the s-axis, 20, 40, 60, 80. Can distribute that to 20, 60, 80, 100. So if I do that, I have 1 mark, appropriate scale. This is 1 mark. So even without plotting the graph, if you can take care of your axis and your scale, and most time from the question of the graph to plot, they already giving you 1 free mark with the unit. So all you need to do, just transfer this and you get this free mark here. What is the label for the y-axis? R, resistance, and the unit is ohm. Just write it there. What is the unit of the horizontal axis? Length measured in cm. Write it there. So for doing that, this is a free mark. The first mark is free one. So then the second mark is your ability to distribute the value into this. So the next one is a plotting. So you plot your value for the first one. When the length was 20, 1.5. When the length was 40, resistance was 3.6. When the length was 60, resistance was 4.2. When the length was 80, resistance was 6.6. When the length was 100, the resistance was 8.3. So you draw your line of best fit. So if you look at it, this point is at anomalous and this point is at anomalous. So 3 of them, 1 to the right, 1 to the left. So line of best fit, you get your 4th mark. This 3rd mark for plotting, getting this plot. So you have to plot it carefully because the examiner is going to measure and look at it. So now to determine the gradient is 1 mark. All you need to do, this is the graph. I just transferred it to this point. So you draw your triangle. And how do you get your triangle? Where the line, your straight line, cross the grid at right angle. So you see this point and this point here that I pick. So you can see the cross. and then your gradient your triangle must be more than half of your line. So let's look at that. The horizontal, the vertical variation, the rise, so it's from 2 to 6. So you have delta R over delta L. That is going to give you the gradient. So if you look at this, then you cannot find the run. So what is the difference in the length? So from the beginning to the end here, so you get those values. Then you calculate your gradient. How did you get the unit of your gradient? The unit of the vertical y-axis divided by the unit of the s-axis. So now ohm per cm. So which is the resistivity, resistance per unit length of the wire. So what is the range of the gradient, acceptable range? From 0.073 to 0.093. So that means our value is correct within in this result. The next question. Now the gradient G is numerically equal to resistance per unit length R0 of the. Now write down a value for R0 for this experiment. This critical reasoning. This question is a giveaway. The gradient is numerically equal to resistance per unit length. So you've told, so whatever you get as your G, write it as your R0. So G is approximately this. So whatever we get as G, just write it here as a resistance per unit length, which is 0.08 ohm per cm. Suggest one practical reason why students carry out this experiment may not obtain same reading as in figure 3.1. Assume that the procedure has been done carefully. This is another aspect of the course that I want us to emphasize. Scientific inquiry, analysis, evaluation, and conclusion. Your ability to describe the accuracy of prediction based on results and suggest why they were not accurate. So now this investigation was not done by you, but they want to test this, your understanding of this aspect of the course. So you must be able to know when an experiment has been done properly, and then why the person carry out the investigation will have accurate result, and then what is the experimental mistake that they should look out for. So in this case, so let's look at it. Number one, the difficulty to position crocodile clip accurately in order to measure the length of the wire. That is a major problem as you are trying to measure the length of the wire. If the crocodile clip is not firm enough, it can easily slip up and then introduce error in your measurements. So when you are measuring the length of 20 cm, the thing can increase to another length without you knowing. So you have that. Then another issue again is that the constatant wire that you are using, the resistance wire, is possible that it is not uniform. So the dimension is not uniform. So then inconsistent connection with the crocodile clip. Then we have the resistance wire not being uniform can also introduce. So these are sources of error why students may not have the same reading. So if they give you the same wire and they ask you to repeat the same experiment, these are the three major reasons why you might not have the same value that were recorded on table 3.1. So now a student investigate the motion of the air. Plan an experiment which will enable him to investigate how the range of the ball depends on the angle it is launched. Now the range is the horizontal distance that the ball travels after leaving the end shown in figure 4.1. So the channel here, once the ball leaves here and then it falls to this point, so the distance, this is the range. So the distance from the end of this flexible end of the channel to where the ball will drop. The apparatus available are a flexible channel, this, which can be bent to different angle, a selection of ball, each of different diameter and mass. In your plan, you should list any additional apparatus needed, explain briefly how to do the experiment. You may add to your explanation. So these points are your scoring points. So you have the, so 1, this is the main scoring point. So you have 1 mark here, 2 mark, 3 mark, 4 mark, 5 mark. Then the next additional mark you have for repeating your value, 6 mark. And then any other thing you do again to ensure that you carry out the investigation accurately, 7 marks. So that is the 7 mark for this question. So let's go and discuss how you. So the first aspect of the investigation, list any additional material you will need. Here I've listed about 4 additional materials that you will need. 1, you need the meter rule, which is not given, to measure the length, to measure the range of the ball. You need protractor to measure the angle of launch that you will bend the flexible channel to. Then retor stand used to clamp the channel to a position. Then a sound tray which the ball will land into, so that you can use it to know where the ball drop precisely, and you can measure the range. So this one, for stating this thing, you have your first mark. Then the second major aspect of the planning, briefly explain how to do the experiment. You may add to figure 4.1 if it will help your explanation. Very good. So the method, so this is figure 4.1. So we have this, you have the flexible clamp given to you. So you need to indicate the height. So now what I've done is I clamp it, because you can't hold it in one position and carry out the experiment. So you clamp it to a position on a retor stand, then with a clamp. Then this flexible angle here, you adjust it. So the theta, you can adjust the angle. So from this initial position to this place, that is theta. So I'm going to start with 20 degrees. Then the height of this end here, h, so I keep it here, this height of this flexible, and I will keep it at the height of 1 meter throughout the experiment. So let's see how the procedure. Then I put a sand tray here, so when the ball fall off, it will land here, so I can know where it drop. Then the distance from this end to where the ball will drop, that will be the range that we are measuring. So we want to see how the value of the angle here will affect the distance, the range r. So let's see. So I drop the ball. Do you notice that? So let's repeat it again. I drop the ball from this point, so he roll down, and then he fall off and land in this place. So the distance here is the range. Did you see that? So let's repeat it the 3rd time. So you drop the ball at this point, I allow it to roll, then it falls to this point, going. So let's go. Okay, very good. So you do that. Now, so let's see the procedure. What do we do? Number 1, I fix the channel at a constant height of 100 meters above the floor and clamp it to the retor stand. Then 2, I set the launch angle at 20 degrees, drop the ball near the clamp and allow it to roll. I measure the range r of the ball. I repeat the procedure and calculate the average range. So for doing this one, I get another mark. That is the second mark. Then the second one, I can now say I flatten the sand bay where the ball drop, so that when it drop again, it will not confuse. I can now know the exact point where the ball drop on this sand tray. So I flatten the sand. Okay, then I will vary the angle, increase the angle. I increase it to 30. Then next again, I increase it to 40, 50 and 60 degrees. So I vary the angle, increase the angle, then repeat the procedure. I repeat this step 2 again. Drop the ball from this point, allow it to roll, and then it drops at this point. Then for each angle, I repeat the investigation twice, so to eliminate error. So then I repeat the procedure for launch angle of 40, 50 and 60. So I have it like how many times repeated? 21, 32, 43, 54, then 60. So I've repeated at least 5 sets of reading. So now for this repeated set of reading, I have 1 more additional mark. Then for repeating it for each set, for every angle I repeat the process, I have 1 mark. So already we have have 1 mark, 2 mark, then for repeating 4 mark, and then for repeating the set here another mark, that is 4 mark already, but the mark will be scored in the next point. So we have 2 main scoring points. So let's go. Now the scoring point 3, I repeat the rolling of the ball for different angle. So I've already said that. Now state the key variable to keep constant so that you can have a fair test. So what are the key variable, control variable? I kept the following variable constant: the diameter of the ball I use, so I'm using the same ball. I'm using mass of the ball. I'm using the same marble ball throughout the experiment. The height of upper end of the channel and the initial point of dropping the ball to roll down. So I kept all these value constant, so my experiment will be a fair test. So for doing this, the variable kept constant, I have 1 mark. So we have, so let's go now. Draw a table with column heading to display this and with the unit. So when you draw your table, always indicate the unit. So now let's see. Now the table must show the independent, which is the angle, and then the dependent. Because we vary the angle, we now be able to measure the range. So in this particular experiment, the range is the dependent variable, while the angle of launch is the independent variable. So you have this, the angle is in degree, measured in degree, then the range in centimeter. So for doing this, you have your 1 mark. Then the next thing, explain how to use your result to reach a conclusion. So we are going to analysis. So to do this, I compare reading in the table to see if change in the angle of launch produce a change in the range measured, and then I plot the graph of range on y-axis and the angle of launch on s-axis. For stating this, I have 1 mark. Then so this is the what I'm saying. So the angle of launch, independent variable, then the range, your dependent variable. So you plot this so you show this, either you draw this, and then the next thing is there are some points that extra additional scoring point which give you the 7th mark. So for stating, already we have already mentioned this and we are discussing the experiment, but let's just highlight it. What are the additional points? So up to this point we have 6 mark out of the 7 mark. So but there is 1 extra mark that you will get, which is not necessarily stated as the scoring point. But what are the, so for repeating, for measuring for 5 sets of data, like in this experiment, we varied the launch angle from 20, 30, 40, 50, and 60 degrees. So we have 5 sets of data. So this one, 1 mark. Then repeat each measurement and take average. So for every angle, we repeated the rolling twice, and then we got the range and we calculated the average. So for doing this one, 1 mark, but you are just going to be scored. So if you, for this set of data, so we already have the 7 mark, but let's just say in case, then the means of accurate indication of points at which the ball hit the floor, like the use of the sand tray, which is extra material, but it was not given in this experiment that we wrote out. So for showing that sand tray in the setup, we have 1 mark. Then clear indication of where the ball to measure the range, like on the diagram we showed it. When on the animation we show where the range will, with that arrow, the distance that we measure marked as range. So for these ones, so these are the additional scoring points. But out of this 1, 2, 3, 4, 1 additional mark will be added to the 6 mark you already have to give you the 7 mark. So congratulations, this is how to report your planning of investigation. Feel free to ask any question. Subscribe to Super Easy Physics and Mathematics. And because I know you are a student that wants to get good grade in physics, that's why you are previewing this past question with me. I wish you good luck in your next examination.
You are a brilliant student who wants to succeed. Please subscribe so that you keep up to date, because more tutorials solving past exam questions to assist you will be uploaded.